When we measure, we attempt to identify the dimensions, quantity, capacity, or degree of something. Measurement is formally defined as the act of measuring by assigning symbols or numbers to something according to a specific set of rules. Measurement can be categorized by the type of information that is communicated by the symbols or numbers assigned to the variables of interest. In particular, there are 4 levels or types of information discussed in this chapter. They are called the 4 scales of measurement. The first scale of measurement is called the nominal scale. This is a non-quantitative measurement scale. It is used to categorize, label, classify, name, or identify variables. It classifies groups or types. Numbers can be used to label the categories of a nominal variable, but the numbers serve only as markers, not as indicators of amount or quantity. For example, if you wanted to, you could mark the categories of the variable called gender with 1 equal female and 2 equal male. Some examples of nominal level variables are the country you were born in, college major, personality type, experimental group, for example, experimental group or control group. The second type is called an ordinal scale. This level of measurement enables one to make ordinal judgments, that is, judgments about rank order. Any variable where the levels can be ranked, but you don't know if the distance between those levels is the same, is an ordinal variable. Some examples are order of finish position in a marathon, Billboard Top 40, and rank in class. The third type is called the interval scale. This scale or level of measurement has the characteristics of rank order and equal intervals. That is, the distance between adjacent points is the same. It does not possess an absolute 0 point. Some examples are Celsius temperature, Fahrenheit temperature, and IQ scores. Here's the idea of the lack of a true 0 point. 0 degrees Celsius does not mean no temperature at all. In a Fahrenheit scale, it is equal to the freezing point, or 32 degrees Fahrenheit. 0 degrees in these scales does not mean 0, or the absence of temperature. The ratio scale is the 4th level of measurement. This is the only scale with a true 0 point. It also has all of the lower level characteristics, that is, the key characteristics of each of the lower level scales, of equal intervals for the interval scale, rank order for the ordinal scale, and ability to mark a value with a name, the nominal scale. Some examples of ratio level scales are number correct, weight, height, response time, Kelvin temperature, and annual income. Here's the example of the presence of a true 0 point. If your annual income is exactly $0, then you earned no annual income at all. You can buy absolutely nothing with $0. 0 simply means 0. The purpose of this section is to show you how measurement experts think, including their key operating assumptions. Before I list these assumptions, which are shown in Table 6.4 of your text, note the difference between testing and assessment. According to the definitions that we use, testing is the process of measuring variables by means of devices or procedures designed to obtain a sample of behavior. An assessment is the gathering and integration of data for the purpose of making an educational evaluation, accomplished through the use of tools such as tests, interviews, case studies, behavioral observation, and specifically designed apparatus and measurement procedures. In Table 6.3, the authors list the 12 assumptions made by professional test developers and users. These assumptions are important for testing and assessment. Assumption number 1. Psychological traits and states exist. A trait is a relatively enduring, that is, long-lasting, characteristic on which people differ. A state is a less enduring or more transient character on which people differ. Traits and states are actually social constructions, but they are real in the sense that they are useful for classifying and organizing the world. They can be used to understand and predict behavior, and they refer to something in the world that we can measure. Second, psychological traits and states can be quantified and measured. For nominal scales, the number is used as a marker. For the other scales, the numbers become more and more quantitative as you move from ordinal scales, which show ranking only, to interval scales, which show amount but lack a true 0 point, to ratio scales, which show amount or quantity, as we usually understand this concept in mathematics or everyday use of the term. Most traits and states measured in education are taken to be at the interval level of measurement. Third, a major decision about an individual should not be made on the basis of a single test score, but rather from a variety of different sources. For example, different tests of intelligence tap into somewhat different aspects of the construct of intelligence. Information from several sources usually should be obtained in order to make an accurate and informed decision. For example, the idea of portfolio assessment is useful. Fourth, various sources of error are always present in testing and assessment. There is no such thing as perfect measurement. All measurement has some error. The authors define error as the difference between a person's true score and that person's observed score. There are two main types of error: random error, which is error due to transient factors such as being sick or tired, and systematic error, which is error present every time the measurement instrument is used, such as an essay exam being graded by an overly easy grader. Later, when we discuss reliability and validity, you might note that unreliability is due to random error, and lack of validity is due to systematic error. Test-related attitudes and behaviors are the fifth assumption, in that they can be used to predict non-test-related attitudes and behaviors. The goal of testing usually is to predict behavior other than the exact behaviors required while the exam is being taken. For example, paper and pencil achievement tests given to children are used to say something about their level of achievement. Another paper and pencil test, also called a self-report test, that is popular in counseling is the MMPI, which stands for the Minnesota Multifaceted Personality Inventory. Client scores on this test are used as indicators of the presence or absence of various mental disorders. The point here is that the actual mechanics of measurement, for example, self-reports, behavioral performance, or projective, can vary widely and still provide good measurement of educational, psychological, and other types of variables. Perhaps the most important reason for giving tests is to predict future behavior. Tests produce a sample of present-day behavior. However, this sample is used then to predict future behaviors. For example, an employment test given by someone in a personnel office may be used as a predictor of future work behavior. Another example, the Beck Depression Inventory, is used to measure depression and, importantly, to predict test takers' future behaviors. For example, are they at a risk to themselves? Sixth, with much work and continual updating, fair and unbiased tests can be developed. This requires careful construction of test items and testing of the items on different types of people. Test makers always have to be on the alert to make sure tests are fair and unbiased. This assumption also requires that the test be administered to those types of people for whom it has been shown to operate properly. Seventh, standardized testing and assessment can benefit society if the tests are developed by expert psychometricians and are properly administered and interpreted by trained professionals. Many critical decisions are made on the basis of tests. For example, teacher competency, employability, presence of a psychological disorder, degree of teacher satisfaction, degree of student satisfaction, etc. Without tests, the world would simply be much more unpredictable. As mentioned earlier in this chapter, good measurement is fundamental for research. If we do not have good measurement, then we cannot have good research. That is why it's so important to use testing and assessment procedures that are characterized by high reliability and high validity. As an introduction to reliability and validity and how they are related, note the following. Reliability refers to the consistency or stability of test scores. Validity refers to the accuracy of the inferences or interpretations that we make from those test scores. Reliability is a necessary but not sufficient condition for validity. That is, if you are going to have a valid test, it must also be reliable. But reliability in and of itself is not enough to ensure validity. Assume you weigh 125 pounds. If you weigh yourself 5 times and get 135, 134, 134, 135, and 136, then the scale or scales you used were reliable, but it wasn't valid. The scores were consistent, but they were wrong. Again, you want your scales to be both reliable and valid. Reliability refers to consistency or stability. In psychological and educational testing, it refers to the consistency or stability of the scores that we get from a test or assessment procedure. Reliability is usually determined using the positive values of a correlation coefficient, and this correlational index is called a reliability coefficient in this context. Here's a review point from the Chapter 2 material. Recall that a correlation coefficient is a measure of the relationship that varies from -1 to 0 to 1, and the farther the number is from 0, the stronger the correlation. For example, -1, -1.00, indicates a perfect negative correlation. 0 predicts no correlation at all, and +1 plus 1.00 indicates a perfect positive correlation. Regarding strength, -0.85 is stronger than +0.55, and +0.75 is stronger than +0.35. When you have a negative correlation, the variables move in opposite directions. For example, as poor diet increases, life expectancy decreases. When you have a positive correlation, the variables move in the same direction. For example, as education increases, income also tends to increase. When looking at reliability coefficients, we are interested only in the positive values ranging from 0 to 1. That is, we are only interested in positive correlations. The key point here is that 0 means no reliability, and +1 means perfect reliability. Reliability coefficients of 0.70 or higher are generally considered to be acceptable for research purposes. Reliability coefficients of 0.90 or higher are needed to make decisions that have impact on people's lives. For example, clinical uses of tests. Reliability is empirically determined. That is, we must check the reliability of test scores with specific sets of people. That is, we must obtain the reliability coefficients of interest to us. There are 4 primary ways to measure reliability. The first type of reliability is called test-retest reliability. This refers to the consistency of test scores over time. It is measured by correlating the test scores obtained at one point in time with the test scores obtained at a later point in time for a group of people. A primary issue is identifying the appropriate time interval between the 2 testing occurrences. The longer the time interval between the 2 testing occasions, the lower the reliability coefficient tends to be. The second type of reliability is called equivalent forms reliability. This type refers to the consistency of test scores obtained on 2 equivalent forms of a test designed to measure the same thing. It is measured by correlating the scores obtained by giving 2 forms of the same test to a group of people. The success of this method hinges on the equivalence of the 2 forms of the test. The third type of reliability is called internal consistency reliability. This term refers to the consistency with which the items on a test measure a single construct. Internal consistency reliability only requires one administration of the test, which makes it a very convenient form of reliability. One type of internal consistency reliability is split half reliability, which involves splitting a test into 2 equivalent halves and checking the consistency of the scores obtained from the 2 halves. The measure of internal consistency that we emphasize in this chapter is coefficient alpha, which is also sometimes called Cronbach's alpha. The beauty of coefficient alpha is that it is readily provided by statistical analysis packages, and it can be used when test items are quantitative and when they are dichotomous, as in right or wrong. Researchers use coefficient alpha when they want an estimate of the reliability of a homogeneous test, that is, a test that measures only one construct or trait, or an estimate of the reliability of each dimension on a multidimensional test. You will see it commonly reported in empirical research articles. Coefficient alpha will be high, for example, greater than 0.70, when the items on a test are correlated with one another. But note that the number of items also affects the strength of coefficient alpha. That is, the more items you have on a test, the higher coefficient alpha tends to be. This latter point is important because it shows that it is possible to get a large alpha coefficient even when the items are not very homogeneous or internally consistent. The fourth and last major type of reliability is called interscorer reliability. Interscorer reliability refers to the consistency or degree of agreement between 2 or more scorers, judges, or raters. You could have 2 judges rate one set of papers. Then you would just correlate their 2 sets of ratings to obtain the interscorer reliability coefficient, showing the consistency of the 2 judges' ratings. Validity refers to the accuracy of the inferences, interpretations, or actions made on the basis of test scores. Technically speaking, it is incorrect to say that a test is valid or invalid. It is the interpretations and actions taken based on those test scores that are considered valid or invalid. All of the ways of collecting validity evidence are really forms of what we used to call construct validity. All that means is that in testing and assessment, we are always measuring something. For example, IQ, gender, age, depression, or self-efficacy. Validation refers to gathering evidence supporting some inference made on the basis of test scores. There are three main methods for collecting validity evidence. The first method is called evidence based on content. Content-related evidence is based on a judgment of the degree to which the items, tasks, or questions on a test adequately represent the domain of interest. Expert judgment is used to provide evidence of content validity. To make a decision about content-related evidence, you should try to answer these three questions. First, do the items appear to represent the thing you are trying to measure? Second, does the set of items underrepresent the construct's content? That is, have you excluded any important content areas or topics? And third, do any of the items represent something other than what you are trying to measure? That is, have you included any irrelevant items? The second method is evidence based on internal structure. Some tests are designed to measure one general construct, but other tests are designed to measure several components or dimensions of a construct. For example, the Rosenberg Self-Esteem Scale is a 10-item scale designed to measure the construct of global self-esteem. In contrast, the Harter Self-Esteem Scale is designed to measure global self-esteem as well as several separate dimensions of self-esteem. The use of the statistical technique called factor analysis tells you the number of dimensions, that is, factors, that are present. That is, it tells you whether a test is unidimensional, just measuring one factor, or multidimensional, measuring two or more factors. When you examine the internal structure of a test, you can also obtain a measure of test homogeneity, that is, how well the different items measure the construct or trait. The two primary indices of homogeneity are the item-to-total correlation, that is, correlate each item with the total test score, and coefficient alpha, discussed earlier under reliability. The third type is evidence based on relation to other variables. This form of evidence is obtained by relating your test scores with one or more relevant criteria. A criterion is the standard or benchmark that you want to predict accurately on the basis of the test scores. Note that when using correlation coefficients for validity evidence, we call them validity coefficients. There are several different kinds of relevant validity evidence based on relations to other variables. The first is called criterion-related evidence, which is validity evidence based on the extent to which scores from a test can be used to predict or infer performance on some criterion, such as a test or future performance. Here are the two types of criterion-related evidence. The first type is concurrent evidence. Concurrent evidence is validity evidence based on the relationship between test scores and criterion scores obtained at the same time. Predictive evidence is validity evidence based on the relationship between test scores collected at one point in time and criterion scores obtained at a later time. Here are three more types of validity evidence researchers should provide. The first is called convergent evidence. Convergent evidence is validity evidence based on the relationship between the focal test scores and independent measures of the same construct. The idea is that you want your test that you are trying to validate to strongly correlate with other measures of the same thing. The second type is called discriminant evidence. Discriminant evidence is evidence that the scores on your focal test are not highly related to the scores from other tests that are designed to measure theoretically different constructs. This kind of evidence shows that your test is not a measure of those other things, that is, those other constructs. Putting the ideas of convergent and divergent evidence together, the point is to show you that a new test measures what it is supposed to measure, and that you want it to correlate with other measures of that construct from convergent evidence, but you do not want to correlate strongly with other things measures for divergent evidence. You want your test to overlap with similar tests and to diverge from tests of different things. In short, both convergent and divergent evidence are desirable. Known groups evidence is also useful in demonstrating validity. This is evidence that groups that are known to differ on the construct do differ on the test in the hypothesized direction. For example, if you develop a test of gender roles, you would hypothesize that females will score higher on femininity and males will score higher on masculinity. Then you would test this hypothesis to see if you have evidence of validity. You must be careful when interpreting the reliability and validity evidence provided with standardized tests and in empirical research journal articles. With standardized tests, the reported validity and reliability data are typically based on a norming group, which is an actual group of people. If the people with which you intend to use the test are very different from those in the norming group, then the validity and reliability evidence provided with the test becomes questionable. Remember that what you need to know is whether a test will work with the people in your classroom or in your research study. When reading journal articles, you should view an article positively to the degree that the researchers provide reliability and validity evidence for the measures that they use. Two related questions to ask when reading and evaluating an empirical research article are, is this research study based on good measurement? And, do I believe that these researchers used good measures? If the answers are yes, then give the article high marks for measurement. If the answers are no, then you should definitely invoke the GIGO principle. Garbage in, garbage out. Three primary types of educational and psychological tests are discussed in your textbook: intelligence test, personality tests, and educational assessment tests. Intelligence has many definitions because a single prototype does not exist. Although far from being a perfect definition, here is the author's definition. Intelligence is the ability to think abstractly and to learn readily from experience. Although the construct of intelligence is hard to define, it still has utility because it can be measured and it is related to many other constructs. For some examples of intelligence tests, click on Intelligence Tests under Bonus Materials on the companion website. Personality tests. Personality is a construct similar to intelligence in that a single prototype does not exist. Here is the author's definition. Personality is the relatively permanent patterns that characterize and can be used to classify individuals. Most personality tests are self-report measures. A self-report measure is a test-taking method in which the participants check or rate the degree to which various characteristics are descriptive of themselves. Performance measures of personality are also used. A performance measure is a test-taking method in which the participants perform some real-life behavior that is observed by the researcher. Personality has also been measured with projective tests. A projective test is a test-taking method in which the participants provide responses to ambiguous stimuli. The test administrator searches for patterns on participants' responses. Projective tests tend to be quite difficult to interpret and are not commonly used in quantitative research. For some examples of personality tests, click on Personality Tests under Bonus Material on the companion website. The third type of tests are educational assessment tests. Within these, there are 4 subtypes. The first type is called preschool assessment tests. These are typically screening tests because the predictive validity of many of these tests is weak. The second type are called achievement tests. These are designed to measure the degree of learning that has taken place after a person has been exposed to a specific learning experience. They can be teacher-constructed tests or standardized tests. For some examples of achievement tests, click on Standardized Achievement Tests under Bonus Materials on the companion website. The third type are classified as aptitude tests. These tests focus on information acquired through the informal learning that goes on in life. They are often used to predict future performance, whereas achievement tests are used to measure current performance. And finally, diagnostic tests. These tests are used to identify the locus of academic difficulties in students. The 2 most important main sources of information about tests are the Mental Measurements Yearbook, the MMY, and Tests in Print, the TIP. Some additional sources are provided in Table 6. This presentation was built using the original PowerPoint presentation and lecture notes provided by authors Johnson and Christensen on the instructor and student websites, which accompany the 4th edition of Educational Research, Quantitative, Qualitative, and Mixed Approaches. I have modified the slide content and script to match our needs, but the original content is still copyrighted by Sage Publication.